Hi everyone, this video is about differentiation, as you can see by the title, and the basic formula for differentiation is this one in pink, which states that if you have a function in the form x to the n, its derivative is just going to be nx to the n minus 1. So as you can see, the power becomes a coefficient, and the new power of the derivative is just going to be n minus 1. Okay, so let's look at an example, which is the one in green. So if we have the function f of x equals x squared, we can see by comparing these two, by comparing the general formula or function with the example, that n is 2. So the derivative is going to be 2x, since the power, which is 2, becomes a coefficient, and the new power is just going to be 2 minus 1, n minus 1, which is 1. Okay, so I would like you to try these four problems. So I want you to differentiate these four functions. I would like you to pause the video right now. Otherwise, you can, if you do not know how to solve them, or you don't want to try to solve them, or you just don't want to try solving them, continue and I will solve them right now. Okay, so this one is a rather easy one, but as you can see, you always want to have your function in this format. So we have that f of x equals x to the minus 3. As you can see now, we have it in the form x to the power of n, where n is minus 3. Okay, so let's continue with this one. So the derivative of f of x is just going to be minus 3 x to the minus 3 minus 1. So the derivative is just going to be minus 3x to the minus 4. Easy, right? Okay, so we'll move on to the next one. Okay, so this one, we want to put it in the format that is given to us in the formula. So in this case it would be x to the 1/3, where n is 1/3. So the derivative is 1/3 of x to the 1/3 minus 1, which is the same as 1/3 of x to the minus 2/3. That's it. It's really quite easy. Ooh, that's a really bad line. Okay. It's really quite easy. I think the best thing is just to know your formula, and it should be really straightforward if you know the formula well. So that's the most important thing, to know your formulas. Okay, let's get to the next one. So this one is just really the same thing, but in this case, you just need to differentiate each component separately. So let's see. So first of all, as always, we'll put every single one of these components in the form x to the n. The coefficient doesn't matter, since it's just multiplying the x to the n, so it doesn't bother us. So we'll start with 6x to the 3, which is in the perfect form, plus 2x to the minus 1/3 minus x to the minus 3 plus 6. That should be fairly easy. So now we can get on with the differentiation. So this is just going to be 6 times 3 x to the 3 minus 1 plus 2 times minus 1/3 of x to the minus 1/3 minus 1 minus 3 times x to the minus 3 minus 1 plus, okay, so this one, you would think, okay, but there's no x in this one. Well, let's put an x right there. But you think, okay, well, but it's 6, not 6x. Yeah, but let's put 6x to the power of 0. And because x to the power of 0 is 1, since anything to the power of 0 is 1, it's the same as 6, because since 6 times 1 is just 6, right? So this would be, the derivative of this is 0, since 6 times 0 to the power of x to the power of 0 minus 1 is 0. So really we could just cross that out since it's 0. Okay, so this is equal to 18x to the power of 2 minus 2/3 times x to the power of minus 4/3 plus 3x to the power of minus 4. And that's it. Okay, let's get on to the next one. This one I think is easier, but I mean, the more practice you get, the better you'll get at differentiating. So in this case we have f of x equals x to the minus 1/2 plus x to the minus 1. So the derivative is going to be minus 1/2 of x to the minus 1/2 minus 1 plus x to the power of minus 1. Oh, I just made a mistake. It's actually really easy to make mistakes in differentiation because any single stupid mistake is just going to mess up the whole thing. So be careful, not like me. Okay, so this is equal to minus 1/2 of x to the power of minus 3/2 minus x to the minus 2. So that's that. Okay, so that's great, we've solved these problems, but you might be wondering, okay, but what is a derivative? What am I actually doing? So a derivative is actually the gradient of a graph. You can take a function, you differentiate it, and you can quickly tell how steep a graph is. Okay, so for example, if we have the function sine x, I'm not sure if you've come across this graph or not, but basically if you draw a cos diagram at 0 degrees, it's at 0, and then at 90 degrees it's actually at 1, and 180 degrees it's at 0 again, and at 270 degrees it's at minus 1, 360 it's going to be at 0 again, and it just repeats itself every 360 degrees. But for the sake of not making this video too long, I am just going to go up till 360. Okay, so we'll look at this tangent for a second. So as you can see, the gradient of this tangent at the point 90 degrees, x is 90 and sine is 1. The gradient is actually 0, so the derivative should be 0. We'll see an example. So actually we're going to do this algebraically so that you see that it's going to be 0 algebraically as well. So we have f of x equals sine x, so the derivative of sine x is actually cos x. Just need to learn this. So derivative when x equals 90 degrees is 0. You can put cos of 90 in your calculator and you should get 0, otherwise your calculator doesn't work. Okay, and you could do the same in radians, it doesn't matter, but that's not really the point of this video. So okay, so let's look at another tangent. We're going to look at this point right here. So this is the point 180 degrees when sine is 0. So we're also going to do this algebraically. When x is 180 degrees, cos of 180 degrees is actually -1, which makes sense since, as you can see, the gradient is negative of this line, of this tangent, so the derivative is also going to be negative, and we can see that the gradient, or the derivative, is -1. So this is the end of this video. I hope that you learned something from it, and please leave comments below if you have any questions, or just a comment on the video, and thank you for watching.